freeze like a mannequin, freeze like a mannequin, pause and hold it like a mannequin, freeze like a mannequin, freeze like a mannequin, pause and hold it like a mannequin, like a mannequin, like a mannequin. Get your homies chilling and start recording like a mannequin, like a.
Hi, Assalamualaikum, and I'm going to talk about BJT amplifier low frequency response. I will be explaining about the introduction. As you can see, this is the circuit of the loaded BJT amplifier with capacitor that will affect the low frequency response. From the circuit, you can see CS, CC, and also CE. Now, we're going to discuss about CS. Since CS is normally connected between the applied source and the active device, the general form of RC configuration is established by the network in the figure given. The total resistance is now Rs plus Ri, and the cutoff frequency is FLS equal to 1 over 2 pi in bracket Rs plus Ri times CS. For CC, since the coupling capacitor is normally connected between the output of the active device and the applied load, the RC configuration that determines the low cutoff frequency due to the CC is appear in the figure given. From this figure, the total resistance is now RO plus RL, and the cutoff frequency is determined by FLC equals to 1 over 2 pi in a bracket RO plus RL times CC. For CE, to determine the FLE, the network seen by CE must be determined as shown in this figure. Once the level of RE is established, the cutoff frequency due to CE can be determined using the following equation. FLE equals to 1 over 2 pi RECE.
Hi, Assalamualaikum. I will be explaining the simulation by using multi-seed. For the simulation, I have using multi-seed to show the result. Firstly, I have do the DC parameter circuit. The circuit is about BJT voltage divider common emitter. This circuit has used in the low frequency response amplifier BJT. Okay, let's see how I did. Okay, this part I using multimeter to check in VB. For this multimeter, we has to know VB because in the calculation we can get the VB. Okay, that VB we have get 3.918 volt. Okay, after this, we have to find out the IA, current of emitter base. Firstly, we have to cut the circuit and series the multimeter. Okay, we have get 1.621 milliampere. Okay. For the AC parameter, we have to put the V signal and the the capacitor to get the low frequency circuit, low frequency response circuit. Okay, let's see what I do. Okay, for this part I have add 3 capacitor and RS and RL. Okay, this part I have to find the VB, V small b. Okay, this part I have to get the V out from the RL point. I use the oscilloscope. Okay, the scope I have to calibrate to see how many I get the voltage. I get voltage at negative 2.77 for the output. As you know, the input 50 millivolt. Okay, this part I had a board plot application in Multisim to see what about plot of this circuit. This what I do. Okay. Okay, that's all for me. Thank you very much.
I'm going to explain about formula. Here are some of things we are going to look in this section. To determine RE for DC condition, we first apply the equation beta RE. Since certified, the DC base voltage is determined by VB equal to R2 VCC divide R2 plus R1 with IE, VE equal to RE. So that RE equal 26 millivolt divide IE and beta RE with the new value of RE. Formula BJT low frequency response has 3 such as CS, CC, CE. For CS, FLS equal 1 over 2 pi times RS plus R1 times CI. VB equal R1 times RS divide RS plus RI equal to R1 parallel R2 parallel beta RE. VI equal RI times VS divide RIs. Okay, CC. FLC equal 1 over 2 pi times R0 plus RL times CC. R0 equal RC parallel R0. Okay, CE. FLE equal 1 over 2 pi times RE times CE. RE equal RE parallel RS divide beta plus RE. AV negative RC divide RE plus RE.
For this presentation, I will conclude that always keep in mind CS, CC, and CE will affect only the low frequency response. At mid-band frequency level and the short circuit equivalent for the capacitor can be inserted. although each will affect again a V equal to VO over VI in similar frequency range. The highest lower frequency cutoff determined by a CL, CC and CE will have a greatest impact since it will be the last encounter before the mid-band level. The frequency relatively far apart, the highest cutoff frequency will essentially determine the lowest cutoff frequency for the entire system. If there are two or more high cutoff frequency, the effect will be to rise the lower cutoff frequency and reduce a resulting bandwidth of the system. In other words, there is an interaction between capacitive elements that can affect the resulting low cutoff frequency. However, if the cutoff frequency established by each capacitor are sufficiently separated, the effect on one the other can be ignored with high degree accuracy. That's all. Thank you.